The next topic is lower triangular matrix. A lower triangular matrix is a square matrix in which the lower triangular part of a matrix is non-zero elements and the upper triangular part is all zeros and none of them is non-zero. So you can see this one, these set of elements are non-zero. These are forming a triangle. Now let us define this and see which elements are 0, which are non-zero. Let us check the indices. If the name of this matrix is M and these are rows and let us call them as I and these are columns, let us call them as J. These are columns and call them as J. Now if I compare I and J, this is 1 1, 2 1, 2 2, 3 1, 3 2, 3 3. So if you check all these indices, I value is greater than or equal to J value. So for non-zero elements, I value is always greater. Then what about zero elements? I value is smaller. So it means if I value is less than J, that is row number is less than column number, then the element must be 0. These must be 0. So we can define a lower triangular matrix as M of I comma J is 0 if I is less than J. M of I comma J is non-zero if I is greater than or equal to J. So these elements are non-zero and those must be 0. Now let us observe in the matrix of n cross n, that is 5 by 5, total 25 elements are there. Then how many elements are non-zero? So number of non-zero elements. First row is having 1 element. Second row is having 2 non-zero elements. Third row is having 3 non-zero elements. So this is for 5. So this is 4 plus 5. Now for any n cross n matrix, it will be 1 plus 2 plus 3 plus goes on to last one will be n. So this is n into n plus 1 by 2 number of elements are non-zero. These many elements are non-zero. In a matrix, total n square elements will be there, n square, and non-zero elements are n into n plus 1 by 2. So if I subtract this, then I get 0 elements. These are 0 elements. So non-zero elements are n into n plus 1 by 2 and 0 elements are n square minus n into n plus 1 by 2. So this will be n into n minus 1 by 2. So if you observe, here is 1 0, these are 2 zeros, then 3 zeros and 4 zeros. Dimensions are 5 cross 5, but the last number of zeros are 4. So this is going up to 1 plus 2 plus 3 plus 4. So that is n into n minus 1 by 2. So there are n into n minus 1 by 2 number of 0 elements and n into n plus 1 by 2 number of non-zero elements. Now let us talk about representing these lower triangular matrices in our program. So when we want to use them in a program, we want to avoid storing zeros so that we can save memory space as well as we can save the time in processing zero elements. Then for storing non-zero elements, how much space we need? There are n into n plus 1 by 2 number of elements, so we need n into n plus 1 by 2 amount of space. So as per our example, how much space we need? So we need 1 plus 2 plus 3 plus 4 plus 5, that is total 15 spaces we require. So let us see how it can be represented. So I will take an array of the size of 15 and we will learn how to store these elements. So here I have an array of 15 spaces of 15 size. Then I can store all these elements in this one. Now how to store these elements? One method is I can store them row by row, and second method is I can store them column by column also. So let us follow row by row method. We can call it as row major method. So first let us see row major method. So let us follow row major. I'll fill the elements row by row. First element, this is A11. So this is row 1. This is row 1. Then row 2, that is A21 and A22. So this is A21 and A22. So this is row 2. Then 3 1 3 2 3 3. So likewise I will fill up all the elements row by row. So here I have filled all the non-zero elements in an array row by row. Here one thing to observe is in this representation I have indices starting from 1 onwards, but as per programming, C or C++ programming, array starts from index 0 onwards. So we have to take care of it. So we have simply stored the element row by row. But is there any formula that is mapping this two-dimensional array, that is lower triangular matrix, in a single dimension array? Let us come up with some formula so that we can access a specific element. So let us see how we can build up a formula. See, suppose I want to access an element that is 4, 3. So 4, 3 is in 4th row. So this is here. So this element I want to access. If I want to access this element, reach this element, then what should be the index of A of 4, 3? What should be the index? 4, 3. So here it is 4, 3, but in this array its index is 8. So I should get 8. So for that, if I start array from index 0, I have to move 8 indices to access this one. So how to know how many indices we have to move? See, this element is in 4th row, this is 4th row. So this will come after 3 rows. So in first row, how many elements are there? Second row, how many? So I have to skip 3 rows. So first row is having just 1 element, then second row is having 2 elements, then third row is having 3 elements. So I have skipped 3 rows. Yes. So I have skipped 3 rows. Now, when I have skipped first row, second row, third row, I am here in the beginning of 4th row. Then how many elements I should move ahead to reach this 4, 3? So when I am here, I should move 1, 2. 2 elements I should move. So plus 2. So if I take total, this is 8. So yes, I got the index. So this is for 4, 3. Let us take one more example and then we will build a formula. Suppose I want to access 5, 4. So 5, 4 is present at 13. So what should be the index of 5, 4? 5, 4 means I should go to 5th row. So for that I should cross over 4 rows. So first row is having 1 element and second is 2 and third is 3. Then 4th row is having 4 elements. So I have skipped first row, second row, third row, 4th row. Then I am here in the beginning of this one. Then from here, how many steps I should take to reach 5, 4? 1, 2, 3. So plus 3. If you add this will be 13. So yes, I got the index. So what is the formula for any I, j? So for any index A of I, j, formula should be, see, this is adding 1 plus 2 plus 3 because it is 4. This is adding 1 plus 2 plus 3 plus 4 because this is 5. So this means for 5, it is 5 into 5 minus 1 by 2. That is sum of n natural number that is less than 5. 1 less than 5. So 1 less than I. So this will be I into I minus 1 by 2. Then plus, see, this was 3, so this was 2. This was 4, so this is 3. So if it is a j, then it will be j minus 1. So this should be the formula for accessing non-zero elements in a single dimension array. This is a row major formula. So we can prepare a program for this one using this formula. We'll be looking at all other matrices. Then finally, I will show you one single program in which I will just change the formula so the matrix will be changing. So at the end, we will see the programming part. Now let us see how we can represent them in column measure. That is, if I am storing the elements column by column.